In this video, we will learn about the relationships between length, area, and volume of similar figures. Now, here's the key right off the bat. It's all about the length scale factor. For example, let's imagine that the length scale factor was 2/3. Then the area scale factor, if you wanted to compare two areas, they won't have a ratio of 2 to 3. Oh no. What you would have to do is, for area, you know how area is always units squared? Well, you have to take the length scale factor and square it. So that's going to be 4/9. Okay? And similarly, for volume, you know how volume is always units cubed? Well, for volume, you have to take the length scale factor and cube it. So for volume, all right, 2 to the third power is 8, and 3 to the third power is 27. So that's the key. That's what we'll be doing. So in problem number 1, find the missing for each pair of similar figures. The missing variable, I guess. Okay, what they gave me, I have the perimeter for both shapes. So that's going to give me the length scale factor. So what I could do is build that scale factor by doing 28/56. Okay, this is length. Now 28/56 reduces, don't you know? That's a scale factor of 1/2. Okay, so the length scale factor is 1/2. So if I want to find x, I can go ahead and use this scale factor of 1/2 to find it. Okay, so we have a ratio, all right, the length ratio is 1 to 2. So x over 16 will equal the length scale factor of 1 to 2. All right, and of course you'd cross multiply. So that's going to give me 2x equals 16 and x equals 8. All right, so far so good. Now here's the key. If the length scale factor is 1/2, what is the area scale factor? Maybe I should write that side by side. Okay, how about area? All right, to get the area scale factor, I need to square this. So the area scale factor is going to be 1 to 4. All right, 1 squared is 1, 2 squared is 4. So if I want to find an area, I'm going to use 1 to 4 as my scale factor. So that's what's going to go on right here. So I'm going to set up my proportion. I'm going to use the scale factor of 1 to 4. All right, so area-wise, the scale factor is 1 to 4. So when I set up my proportion, this will be my area over 144. Okay, 1 to 4, area to 144. And then I'll just cross multiply. So that'll give me 4a is equal to 144. And then if I divide by 4 on both sides, whoa. That's 36. Okay, so that's number 1. Now looking at number 2. Okay, this time is a little bit different. All right, the two numbers they gave me are areas. Very interesting. So let's use that to find the area scale factor. So we're doing area. Okay, so I've got 720 over 1,280. Let's go ahead and reduce that. Okay, so that's 9/16. All right, now that is the area scale factor. We need to use the area scale factor to figure out what the length scale factor is. Okay, let's see. Now remember, let's go back to the black screen for a second. Remember that we have this area scale factor of 9/16. Okay, let's start over. So if we know that the area scale factor is 9/16, and if we know that the area scale factor, if the area scale factor comes from squaring the length scale factor, what scale factor, if we squared it, would give us 9/16? Well, 9 comes from squaring 3, and 16 comes from squaring 4. So we have to think backwards. It's the square root of 9 and the square root of 16. Okay, so if the area scale factor is 9/16, the length scale factor must be 3/4. Okay, so this gives us 3/4 as the length scale factor. So lengthwise, we're talking a ratio of 3:4. So if I have 3:4, then that'll be x to 32 for the length. So this is what I could use to find x. And I would cross multiply. So that would be 4x equals, well, this will be 96. And then you divide by 4. And that's 24. So that's one variable. Now we need to do this perimeter. All right, but perimeter is still a length. So we're still dealing in length. So we will still use the length scale factor that we found of 3/4. Okay, so 3/4, x to 192. All right, or maybe I'll say p this time, p to 192. All right, and you know, cross multiply and stuff. Maybe I should change colors. So this would give me 4p is equal to 3 times 192, 576. And then you divide by 4. And that's 144. All right, and that is it for number 2. Okay, the areas of two similar polygons are in the ratio 64 to 81. So this is an area ratio. Let's go back to that black screen again. Okay, so they're giving us an area ratio of 64 to 81. That's an area scale factor. What is the length scale factor that would give you this area scale factor? Well, 8 squared is 64, and 9 squared is 81. So the length scale factor must be 8/9. All right, so when they say find the ratio of the corresponding sides, that would be the length scale factor. So, like I said, 8 to 9. Oops, I had copied it in the wrong place. Anyway, moving on. Number 4. Two triangles are similar. The sides of the first triangle are 4, 5, and 6. The largest side of the second triangle is 24. Find the perimeter of the second triangle. Okay, I'm going to draw a rough sketch. All right, obviously these drawings are not to scale. But the sides of the first triangle are 4, 5, and 6. Okay, so 4, 5, and 6. All right, the largest side of the second triangle is 24. All right, so I'm going to put that on the same position as the largest side of the first triangle. So because the 6 and the 24 should be corresponding. Okay, those go together. So look, so far that means I have a scale factor of 6 to 24, okay? So, so I have a length scale factor of 6 to 24, so 6 to 24. And of course that reduces down to 1/4. Okay, so I have a scale factor of 1/4. Now, I can use that scale factor to do the perimeter. Okay, because perimeter is just a length. Okay, so look. All right, find the perimeter of the second triangle. So look, what's the perimeter of the first triangle? 4, 5, 6. Okay, 5 plus 6 is 11, plus 4 is 15. So this has a perimeter of 15. Okay, so we are trying to find the perimeter of the big triangle. But let's make a ratio out of it. Okay, so if we go small to big, okay, so that's 15 to P, or I'm just going to call this one P. So 15 to P, then that should equal small to big, 1 to 4. You know, or I could have used 6 to 24, it doesn't matter. But if I cross multiply, 1 times P is P, and 4 times 15 is 60. So the perimeter of the large triangle will be 60. All right, and it makes sense because a scale factor of, let me change colors, a scale factor of 1 to 4 means that these lengths are 4 times as big. So I could just multiply 15 times 4, really. Triangle A is similar to triangle B. If the scale factor of A to B is 4 to 5, what is the ratio of the perimeters of A to B? Okay, and what is the ratio of the areas of A to B? Well, the scale factor ratio is the same thing as perimeter, because scale factor represents length and perimeter is a length. So if the scale factor is 4 to 5, then the perimeters will have a ratio 4 to 5. However, the areas, we'll have to square these, like we said. Okay, just like 8/9 becomes 64 to 81. For area, you square them. Okay, so square this, you get 16. Square this, you get 25. So it'll be 16 to 25 for area. The ratio of the surface areas, all right, the key word is area, of two similar cones is 16 to 49. Okay, I can see where they're going with this, so I'm not even going to read the rest of the question. I'm just going to start thinking. All right, they just told me that the area ratio, I think they said 16 to 49. Is that right? Yeah, 16 to 49 areas. So let's think backwards. What length scale factor would give me this area, considering I have to square it? Well, 16 is 4 squared, and 49 is 7 squared. So the length scale factor must be 4/7. Okay, now, all right, so if they just say scale factor, that automatically means length. Okay, so that's going to be the 4 to 7, like we just decided. See, do they have a space for that? Okay. Okay, now what is the ratio of the volumes? Okay, well, here we go. So now that we know that the scale factor, the length ratio is 4 to 7, to find the volume ratio, we have to cube this. So 4 to the third power and 7 to the third power. Maybe we can do it all at once by doing a fraction. 4/7 to the third power. All right, it's because 4 cubed is 64 and 7 cubed is 343. So 64/343. Or we could write it 64 to 343. All right, so that was number 6. The cones below are similar. What is the volume of the larger cone? All right, so first we'll have to look at the length scale factor and figure that out. So let's see, do we have any corresponding lengths? Yes, we have the 12 and we have the 18. Okay, so if we make a scale factor out of this, it's going to be 12/18, and that's going to reduce down to 2/3. Okay, so this is my length scale factor is 2/3. So if my length scale factor is 2/3, what will be my area scale factor and my volume scale factor? All right, for area, I would square it, and that would give me 4/9. For volume, I would cube it. 2 to the third power is 8, and 3 to the third power is 27. So this would be the ratio of any volumes. Okay, so it's that third one, 8/27. Because we're talking about volume, that's what I'm going to wind up using. Okay, now, so let me switch to purple if I may. So I'm done with lengths now. So I'm switching to purple for volume. So first of all, I need to know what the volume of the first cone is. Now the formula for the volume of a cone is this. All right, maybe I'll write it up here. Volume is equal to 1/3 the area of the base times the height. All right, that's the formula for the volume of a cone. Now this B stands for the area of the base. So I'm going to calculate that off to the side. The area of the base, well, the area of a circle, all right, the base is this circle right here, and that's pi r squared. So that's pi 5 squared. So the base is 25 pi. Okay? Now, I need to take that base and substitute it here into the formula. So that's going to give me that the volume is 1/3 25 pi times 12, because that's the height. Okay, 1/3 25 pi times 12. All right, that is 100 pi. So the volume of the smaller cone is 100 pi cubic feet. All right, but now we're supposed to use that and find the volume of the larger cone. Okay, so the way that we will do that, I'll just highlight this instead of circling it. We will use the scale factor that we found. Remember, the volume scale factor is 8 to 27. All right, so the length scale factor was 2 to 3, but the volume scale factor is 8 to 27. So we will use that to cross multiply. Okay, so let's set up a proportion. 8 over 27. All right, so I guess we're going small to big. Volumes should equal 100 pi over x. Okay, I'm going small to big. So 8 to 27, and then the volumes, 100 pi unknown. So this is the order of the fraction. And then you just cross multiply. So we'll have 8x on this diagonal, and 27 times 100 is 2700 pi. Okay, so then we just have to divide by 8. All right, 2,700 pi divided by 8. Okay, so this would be an exact expression for the volume, 675 pi over 2. Okay, so this is the answer, but sometimes you want a decimal, so that would be 1060.29. Either way, the units will be cubic feet. Okay, that would be the volume of the larger cone, either in exact or decimal form. What else you got? Number 8. Two rectangular prisms are similar, and the ratio of their sides is 2 to 3. All right, the surface area of the larger rectangular prism is this. What's the surface area of the smaller rectangular prism? Okay, so what they are giving us is the length scale factor. Okay, the length scale factor, they said, is 2 to 3. All right, but then they start asking about the surface area. Now we're talking about surface area. So the area scale factor, of course, we square this to find it, is going to be 4 to 9. All right, and it's this area scale factor that we will use to find other information. Now, they're telling us that, let's see, the surface area of the larger rectangular prism is this. Okay, so the large area equals 1,944 square centimeters. How about the small area? Okay, what is the surface of the smaller, what is the surface area of the smaller rectangular prism? Well, so that's what we're trying to find. So, we already know we're going to use the area scale factor of 4 over 9. So let's write that down. Okay, so as we set it up, we're doing 4 over 9. So obviously 4 over 9 is small over big. Alright, now the small area is what we're looking for. The big area is 1944. So that's the setup, and you just cross multiply. So that's going to give us 9x is equal to, let's see, 1,944 times 4. Okay, 7,776. So we will now divide by 9, as you just saw. 864. All right, so this is the smaller surface area. And what kind of units are we talking about? Centimeters? So centimeters squared. Okay, so the ratio of two sides, all right, is 3 to 4. So that is the length, whoa. That's the length scale factor is 3 to 4. All right, now what? The smaller cube has a volume of blah, blah, blah. Okay, what's the volume of the larger cube? Okay, so we have the length scale factor, but now they're asking us about volume. So to get the volume scale factor, we're going to cube this. So the volume scale factor is going to be, well, 3 to the third power is 27, and 4 to the third power is 64. Okay, 27 over 64. So this is the scale factor that we're going to use to solve the problem. Now, they told us that the, all right, the smaller cube, all right, the small volume is 729. And they're asking us for the large volume. Okay. So, using our volume scale factor of 27 to 64, let's set up a proportion. Okay, so we'll have 27 over 64 equals. Now, so I'm doing small over big. So this is small. So 729 will go in the top, and then x is big. So small over big, small over big. And then, of course, you just cross multiply. So along this diagonal, that gives me 27x equals. And 64 times 729 okay, 46,656. Four, 6, 6, 5, 6. Okay, just checking. So, of course, then I would divide both sides by 27. $1,728, 1,728, 1728. And we're talking volume, so it'll be cubic meters. Okay, last problem, number 10. Pyramid X is similar to pyramid Y. The surface area of pyramid X is this. The surface area of pyramid Y is that. Okay, so they are giving us area. Okay, so let's see. So they're giving us area scale factors. So for area, maybe I'll just leave it above here. So they're giving us area. So let's see. 135 and 240. So 135 and 240. Let's reduce that. Okay, that's 9/16. Okay, so we need to use that to figure out what the length scale factor must be. Okay, and remember how it works. All right, we've got 9/16 for area. So then we have to ask ourselves, what length scale factor would give us this, considering that we have to square it? Well, 9 comes from 3 squared, and 16 comes from 4 squared. So the length scale factor must be 3/4. Okay, I'm just double checking my work. Okay, so that's the length scale factor. Now, how about the volume scale factor? Okay, well, once we have the length scale factor, you know to get the volume, you cube it. So we're going back to the length scale factor. 3 cubed is 27. 4 to the third power is 64. So this will be my volume scale factor, 27 over 64. All right, and this is the scale factor that I'm going to need to do this problem. So they said the volume of pyramid X is 189. Okay, now let's keep track. When they gave us those first two, the 135 and the 240, let's see. The 135, that was pyramid X. Okay, so X over Y. So X is the small and Y is the big. Okay, so keeping track of that all the way through, this is X over Y, and this is X over Y. Okay, so when we set up our volume problem to solve, all right, so they gave us the volume of pyramid X is 189. So we're doing X over Y. So 189 will go in the top. And then what is the volume of pyramid Y? Well, that's the thing that we don't know. So that's going to go in the bottom. Okay, and then you just cross multiply like you do. So that's going to give us 27y from this diagonal. Now 64 times 189 is 12,096. All right, divide both sides by 27. $448. All right, that's going to do it for this lesson. I hope this was a helpful video. I know it's a little bit long. I will see you on the next video.